Today is still lesson 4.1, but today we're going to look at solving story problems using linear models, which some aren't so bad and some maybe a little bit different, but still not so bad. So let's just jump in here. Supply and demand. Have any of you taken econ yet? Talk about supply and demand. That's all I remember from econ is supply and demand. I have to admit I hated econ class.
Thanks, that's not giving me any hour for this semester.
Well, you didn't have Mr. Rose.
And I just remember nothing except for talking about supply and demand and gas prices, and I was annoying. But
Well, that's really bad, because we talked about that today. So I think you talked about that Thursday. You didn't really remember.
that's all I remember. Like I got an A in the class. Like it's just worksheets and tests, and you just
You don't give us worksheets.
Yeah.
So. You don't
Well,
give
yeah.
us
We don't get homework.
I had old school econ teachers, so
Yeah,
Me too.
Like, I wasn't gonna say it. I had worksheets. I had the same econ teacher that I had for U.S. history, and I like history, but before every test, I actually would read the chapter because I have a pretty good memory, and so like if I read the chapter, the test questions were like word for word from what was in the book, and so like I would read the chapter the night before the test, and then I could pretty much ace the test because I just remembered it. And my U.S. history teacher like wrote this big note on my paper about how amazing I was and how he was just so glad that I was trying because no one else was trying, and I made him feel worthwhile as a teacher. And I kind of felt bad because I really didn't try that hard. Like I just read the book the night before. But he was so happy. Like I just still remember this big long. But then for our final, we had Scantron, and I don't know if the Scantron machine still does this because I don't use Scantron. But it used to be like when you ran the paper through, the more you got wrong, the more noise it made. And so they would grade your final like in front of the whole class, and so the more noise it made, they were like, "Oh man!" And he ran mine through, and it kind of made a lot of noise. And he was like, "Man, I better check my answer key." And it made me laugh because I didn't study that much for it. But no, I did it right. I mean, horrible for me is like C on the final maybe. So maybe, yeah. I don't know if I ever got a C, but I'm kind of a nerd. You should know that about me by now. I'm a nerd.
I got seen, and I don't know. As long as it's not a mess.
But supply and demand, I should care about econ because it's math. Supply is the amount of product the company is willing to make available for sale at a given price. Demand is the amount, not amount of product that consumers are willing to purchase at a given price. So what do you think the equilibrium price is? So I like to say that's when supply equals demand. So the nice thing in terms of math, when they ask you to find the equilibrium price, all you have to do is set the supply equation equal to the demand equation, and you solve it. So let's look at a problem. It says, suppose that the quantity supplied S and the quantity demanded D of t-shirts at a concert are given by these two equations. S is supply, D is demand, where P is the price of the t-shirt. And so I'm going to do a double page here so we can solve it, and that's why I left you space on your paper. So A says find the equilibrium price for t-shirts at this concert, and then what is the equilibrium quantity. So when it says equilibrium price, it just means you're going to set the supply equal to the demand, and you just solve that equation. Oh my gosh, Taylor's about to get hit. Thought she had her eyes closed. Still wasn't paying attention.
No, I see that. I'm lying.
I thought you were going to get hit by a calculator, like you weren't even scared.
She chose to play it.
Because I have a feeling if I'm going to get hit, the odds are thinking it's going to be more than just like, ah! I would have moved.
Negative 200 plus 50p equals 1,000 minus 25p. We're talking about p represents the number, the price of the t-shirt. So probably we shouldn't get a negative number here. That would mean something's gone wrong. If I'm solving this, I'm going to add 25p over and add 200 over. So I get 75p equals 1200. And when you divide by p, you get that the equilibrium price, the price of the t-shirts where supply with equal demand, is $16. And look at the second part of that, part A. It says, what is the equilibrium quantity? If this is the price, what do you think we're going to do with that to figure out how many t-shirts? Yeah, plug it in for P. Does it matter whether you plug it into supply or demand? No, you should get the same answer because this is the number where supply equals demand. So if you plug 16 into the top or the bottom equation, you should get the same answer. So if I do S of 16, I get negative 200 plus 50 times 16, and what do you get? It should still be the same number. Let's see if we get 50. What did you get? 600? 600. No matter which one you plug it in. So that means the equilibrium price is $16, and at that price, they're saying that they're going to sell 600 t-shirts. Oh, sorry. S of 16, right? I just replaced P with 16. But you could do D of 16 also. What about part B? It says, determine the prices for which the quantity demanded is greater than the quantity supplied. How would I write the equation for where the quantity demanded is greater than the quantity supplied?
Demand greater than supply.
Yeah, here I'm going to erase this. Sorry, yeah, that was my noise of erasing. I kind of didn't realize I was making a noise until you called me out on it. So, but exactly what it says. The quantity demanded is greater than the quantity supplied. So can you just say, solve the equation, 1,000 minus 25p is greater than negative 200 plus 50p? It kind of makes you want to just say 600 because you know the number's going to be 600, but be really careful with the inequality sign. Like it might, well, let me just be quiet for a minute. Jumping ahead. If I like to keep my letters on this side just because I feel like it's easier to read, but if I subtract 50p and I subtract 1,000, I get negative 75p is greater than negative 1,200. And I divide, I'm still going to get 600. Do you agree with me on that? But what happens to my inequality sign when I divide by negative? It flips. So that actually becomes p is less than 600, not greater than 600. Because the easy thing to do would just be like, oh, greater than. Part A was 600, so it's just going to be greater than 600. But that's why you want to make sure you set that up correctly. If you moved your p to the other side, over here, like we did the last one, you would get 600 is greater than p, which is the same as p is less than 600. Not 600, sorry. What's the number? 16, sorry. I was thinking of the 600, you know. Just stop me when you know I'm wrong. No, it's 16. I was doing the quantity instead of the price. So it says when the price is less than $16, it's going to be the quantity demanded is greater than the quantity supplied. I did this last night, and I stopped for a second because it says determine the prices. And I was like, well, I only got one number, so why does it say prices? So you got to think about the implied domain here. What's the lowest price that this shirt could be? Yeah, and actually it can't even be $0. It had to be like bigger than 0, right? Yeah, so when you're writing this, if you look this up in the back of the book, they give an answer to say it's everything less than 16, but also greater than 0. And so we could say greater than $0. And so because these are real life situations talking about money and product, usually 0 is the implied lower limit. You could also give an answer to part B like this, 0 to 16, right? That's the same thing as this. And so just be aware of that. If it's odd today, maybe check the back of the book. We talk about domain. Think about that. What about part C? This is actually an econ question. It just makes you think here. It says, what do you think will eventually happen to the price of t-shirts if the quantity demanded is greater than the quantity supplied? So if people are demanding it more than supplying, what do you think is going to happen to the price? Yeah, the price will go up, because if people want more of it and they don't have it, then the price goes up. That's how to guess. That's all I remember from econ class. Econ? Oh, go. I thought you said econ, and I was like, man, I'm a little hurt by this.
And then you take notes, and then he'll just ramble on about something.
Seems like he truly loves it, though.
He does. Remember what we did yesterday? He asked everyone.
You know I'm recording this, just so you know. He could go and listen to what you're saying.
Oh, well, I don't care. I tell him how I feel about it every day.
Okay, what?
He asked us all how our Christmas vacation was, and after every single person said something, he interrupted, like, he had something to follow up with that. I'm like, you just told us about your Christmas break. Well, let's talk about ours now.
He found out that, you know, like, from Ohio, and they like, they found out like, I did not like him.
Euchre? I love euchre.
I tried playing it one time. It's stupid.
It's really, here's the thing. You gotta play it about 10 times, Lane.
No, it doesn't make sense.
My husband didn't know how to play, and my sister and her husband played, and I played, and so, like, for the first probably, like, 10 to 20 times that we played, my husband had, like, at any moment he could ask us a question, and we would help him. Because, like, he just, like, he didn't understand. He's like, this is dumb, I don't understand. And so at any moment he would be like, so what is this? This is Trump? So this jack is what? And he would, sometimes he would just show us his card and say, what should I play? And you have to do that. You got to do that for like a good, solid at least 10 times, and then you'll finally get it. But just ask lots of questions.
What really cracks me is when people rename.
When they do what?
When they rename.
Oh, yeah. Yeah, you can't.
Yeah, I play, like, when we play, like, okay, I was it's like, renegade, there's 2 points on every team, and, like, if you don't remember what turn it is, no one can tell you.
Oh, that's mean.
Like,
Very nice.
we don't talk.
My sister and I used to always be partners, and then our husbands would be partners, and we would always cheat because, like, my sister, like, would tell me what she had in her hand, so I would call it for Trump. So, like, if she wanted me to do diamonds, she would touch her ring, and then I would know to call diamonds, and we cheat. Yeah.
See, I don't really actually do that game because I count cards.
It's easy to count cards in that game.
Yeah.
All right, this is the other thing, which is something I looked over because I thought that it looked difficult, but it's really not. Straight line depreciation says that this is how some companies depreciate their assets using straight line depreciation. I mean, it's linear, so they're going to say that the cost of something is going down the same amount over time. And so an example of that would be if a car costs $28,000 and they use straight line depreciation over 7 years, could you tell me how much that car is losing value per year? So if it costs $28,000 and we're using straight line depreciation over 7 years, all you do is divide that, and what's 28,000 divided by 7? That means that this car is losing $4,000 per year. So the idea is we want to write equations to show this. And so if you're going to write an equation to show how much this car is worth for X number of years, could we say, I'm just going to use C, or I don't know, W for how much it's worth? Does it make sense that the equation would be, it's $28,000, but I'm subtracting what every year? Minus 4,000x. And so I could say, after 3.5 years, how much is this worth? You just plug 3.5 in for x, and you would get the amount. The problem with this is at some point, it becomes worth 0, right? And so that's the problem with straight line depreciation. It's why I think it's not used a lot in things, because usually, like, it slowly turns, but this makes it easier. This is a linear problem, right? This is the slope, this is the y-intercept. No, like that, like, these would also have a closed domain, like, it would just stop. Like, when it gets down to 0, like, it's worth nothing, and they stop it. Like, so this would say, in how many years, in 7 years, do you agree with me? like it's worth nothing, and they would say, in 7 years, your car is worth 0, buy a new car.
Someone down the line would be like, hey, I'll give you $40,000 for that car.
I don't think they pay you 40,000, but that's the idea there. So let's look at a problem and all the stuff they can ask you about it. I think this is our last problem.
Yeah.
It says, suppose that a company has just purchased a new computer for $3,000. The company chooses to depreciate the computer using straight line method over 3 years. And that's how you'll know to do this on your homework. It'll say they're depreciating it using a straight line method. So part A says write a linear model that expresses the book value V of a computer as a function of its age X. So again, if it's cost $3,000 and we're using the straight line depreciation over 3 years, how much is it losing every year? $1,000. So the idea is if it's losing that much per year, you should be able to write an equation. And I left you space next to it. I'm just going to squish mine in here, I think, and write it up here. And it's always going to be the total cost minus how much it's losing per year. So it costs $3,000 minus 1,000 times X, which is per year. Do you have a question on where I'm getting those values from?
Where'd you get that V from?
Because it just says in the problem to use V for the book value.
That's it, right?
That's A. I'm just writing it above so I can see the problem better. Now look at part B. It says, what is the implied domain of this function? Which means, what values can X be if we're talking about up to 3, I agree with you on that. What about 0? Could it be 0? Like, what is it at when I buy it, how much is it worth? It's still worth 3,000. So I think you should include 0 also. All right, so I think the implied domain, I could write it like this, from 0 to 3, or you could say everything greater than or equal to 0, less than or equal to 3. What is that? We're saying X is time, though, or the age of it. When you buy it, like, it's age 0. Graph the linear equation. What's going to be on my x-axis and my y-axis on this? X represents what? The years that I have it. And we already know it's only from 0 to 3. So you don't need to make a lot of numbers on this, right? Like I'm going to make 1, 2, 3. And what does y represent? Yeah, the cost. Which means, should I make this go by ones on my y-axis? No, what would be a good idea? Thousands would be a great idea. 1,000, 2,000, 3,000. And you could just pick different values and see how much it costs to make your graph. But this is slope-intercept. I kind of have to switch around and have the y-intercept first and the slope last. But this is a y-intercept of 3,000 with a slope is how much it's depreciating each year. 1,000 each year it's losing. So I'm going to go down 1,000 over 1. Down 1,000 over 1. Down 1,000 over 1. And there's no arrows on this graph. It does not keep going. It stops from 0 to 3 years because you can't look at the value before you bought it, and when it gets down to 0, we don't worry about the value anymore. It's no value to us. So to answer part D and E, you can do this with an equation, but you can also use your graph, or maybe you can just think about it. D says, what is the book value of a computer after 2 years? So look at my graph. After 2 years, how much is it worth? Could you also just plug 2 in here for X, and you get 1,000? It doesn't matter which way you do that. What about E? It says, when will the computer have a book value of 2,000? You could say right here, 2,000 is at 1 year, so you can look at your graph. If you were solving this equation, you would put 2,000 in for the value. The value is 2,000, so you could solve that, and you would get after 2 years. Okay, that's not terrible to do, but definitely some story problems. What? Sorry. I almost... Juan said 2, and then I corrected him and wrote the wrong thing. I'm blaming Juan. We only have 4 problems, 37, 40, 46, and 49. One of those problems is just a regular linear equation problem. Like, I think it talks about, like, something costs so much money plus this much per minute or per day or something. Try to write the equation on that. We can look at that one tomorrow if we need to. But the other 3 are just like our problems from our notes. So use your notes to help you, and we'll talk about that tomorrow. And move on to the next lesson.